Hello and welcome to Physics Basket. Today we are going to talk about the class 11 topic 1, wherein we are going to discuss the problems on vectors. So let's get started. The question that we have with us is vector A and vector B. These are two orthogonal vectors. And the values of these vectors are 5i plus 2j plus nk. And the other vector is 4i plus 7nj plus 2nk. And these are basically the orthogonal vectors. And we need to find the value of n. So what is n? So when we are given that the two vectors are orthogonal, this means that vector A is perpendicular to vector B. This is one thing. And as we know, in case of dot product or scalar product, A dot B is A B cos theta. And since it is orthogonal, cos theta is cos 90 degree, which means that A dot B is equal to 0. So the dot product of this and this should ideally be 0. That is what we need to know. So in this case, let's do the dot product of these two vectors, 5i plus 2j plus nk dot 4i minus 7nj plus 2nk. I put the cap everywhere. These are the unit vectors denoted by caps. And this dot product is basically is 0. So in case of dot product, as we know that the multiplication of I to I will be like the unit vectors along the x direction is having the angle equal to 0. So 5 into 4 we need to consider. Similarly, so in this case it is 5 to 4 plus 2 into minus 7n into minus 7n plus this into this, which is minus plus 2n square. This is equal to 0, right? Why we take this? Basically in the background, let's do this. So I, j and k, right? I, j and k are the unit vectors which are the basically orthogonal to each other, perpendicular to each other. So I dot j will necessarily be, since it is orthogonal and both being unit vectors, so I j cos theta, 1 into cos theta and cos 90 degrees 0. So all this I dot j, I dot k or j dot k or k dot j, all this is going to be 0, right? All these are going to be 0. Whereas only I dot I into 1, because I dot I is 1 into cos 0 degree is 1. Similarly, j dot j, so j into cos 0 degree is also 1, and k dot k. So whenever we get to do the dot product of two vectors, which is essentially with all the orthogonal unit vectors I, j, and k, then we can simply multiply the I part alone, the j part alone, and the k part alone, and then that becomes the dot product of the vector, because I part alone will give us the cos 0 degree value and the value of the I part. So this is how we get 5 into 4 plus 2 into minus 7n plus 2 into n square, and that's what 20 plus it becomes minus 14n plus n square equal to 0, which means that n square minus 7n plus 10 equal to 0, which implies n into n minus 5. If we just make it two parts, minus 5n and minus 2n, right? Then minus 5 into minus 2 is plus 1, right? So n into n minus 5 minus 2 into n minus 5 equals 0. And we get n minus 5 into n minus 2 equals 0. So we get n equal to 2 or n equal to 5. These are the values. That's how we do it. So let us start with the next question. It says that a force of 3i plus 2j plus k displaces an object from a point A, which is 2, 3, and 0, to another point B, which is 3, 0, and 1. Find the work done by the force. So first thing is, what is work done? We know work done is basically F dot S. Okay. So the dot product of the force and the displacement. And now we have been given 2 points, A, which is 2, 3, 0, and B is 3, 0, and 1. And what we need to do is we need to find the displacement S, right? So F is already known. F is equal to 3i plus 2j plus k. So we need to find out displacement. So first thing is, what is the position vector of A? We can say that the position vector of A is 2i plus 3j plus 0k, right? Okay. So no need to write. And similarly, position vector of B equal to 3i plus 0j plus last one is 1, right? So this is k. Okay. And the body has moved from A to B. So what is the displacement? S. We can say from position vector B minus P of A, right? And which gives us 3i plus k minus 2i plus j. And this gives us I minus j plus k, right? 3 minus 2 is I, and then minus j plus k, right? So we need to find, now that everything is simple now. So we found the position vector, and with respect to the position vectors, we found the displacement, which is the final position minus the initial position. And then we need to find out W, which is nothing but F dot S. So 3i plus 2j plus k dot I minus j plus k. This gives us, as we know, we need to multiply 3i plus I, 2j to 2j, and k to k. So 3 into 1 is 3 minus 2 plus 1. Okay. So 3 is 4 minus 2 is 2. This is 2j. Right. So this is our answer. Yeah. So here we come with the next question. It says that two forces of equal magnitude act on an object at an angle, okay, such that the resultant is root 3 times that of the magnitude of the vector. Okay. So find the angle between the vectors. So let the forces be F equal to P. Okay. So let us try to draw that. This is also P, the angle be theta, and it says that the resultant R is equal to 3P. Okay, so as we know from the parallelogram law of vector addition, resultant is P square, first vector, plus second vector P square plus 2 into P into P into cos theta. We don't know the theta here, right? So here root 3P equal to 2P square plus 2P square cos theta, which means 3P square equal to 2P square plus 2P square cos theta. Taking 2P square this side, we get P square equal to 2P square cos theta. So we get cos theta is equal to 1 by 2 or theta equal to 60.